Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Water is everywhere, in our bodies, in the food we eat, in the ground. Without water, there'd be no life on Earth. We're here to answer your questions about water, so stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek. And welcome to the Boise Watershed Environmental Education Center. Here you can learn how to conserve and protect water. And we're here to answer your questions about water. But before we do, let's learn a little bit more. Hey kid, what runs but never gets tired? It's water. Water is the most valuable substance on Earth. We couldn't live without it. It fills our lakes, rivers, and oceans. It's in the food we eat and the air we breathe. Nearly 3/4 of our planet is covered in water, and it makes up about 70% of our bodies. The smallest unit of water is a molecule. There are billions of molecules in a single drop of water. A water molecule is comprised of 2 hydrogen atoms and 1 oxygen atom. That's why scientists call water H2O. Water is present in 3 different states. A state describes a physical condition of a thing. When water's cold, it's a solid, like this ice sculpture. When water's warm, it's a liquid, like this waterfall. And when water's hot, it's a gas, like the steam rising from this geyser. So water exists as a solid, liquid, or gas. Water is always on the move. The constant movement of water is called the water cycle. When the sun heats water in the oceans, some of it evaporates, forming clouds. The water falls to the earth as rain, sleet, hail, or snow. Some of this water falls into lakes and rivers, while some seeps into the ground, becoming groundwater. Over time, the water in the rivers and lakes and the groundwater travel back to the oceans, and that completes the water cycle. In Idaho, we use a lot of groundwater. Groundwater is water stored beneath the Earth's surface. It hangs out in the soil, gravel, sand, and rock with holes called porous rock. We dig wells to get groundwater from giant pools called aquifers. An aquifer is a large source of water stored beneath the Earth's surface. We also store water by making lakes called reservoirs. Reservoirs are made by building dams to keep water from flowing away and by digging large holes in the ground to collect rainwater. Water stored in reservoirs can be used to turn a wheel or a turbine to produce electricity. Water can be very powerful. Even a little water over a long period of time can make a huge change in the landscape. When running water wears away soil, it's called erosion. Rivers can form canyons through erosion. Erosion made places like Hell's Canyon. Water can do a lot of damage to human-made things too. Heavy rains can cause floods and landslides. Water is so powerful, it can even break a dam.
Caving is just coming apart. And the water is monumental. Holy, great. People downstream better get out.
97% of the Earth's water is salt water. The remaining 3% of Earth's water is fresh water, but most of the fresh water is frozen in glaciers and icebergs. So less than 1% of all the Earth's water is drinkable. And on average, each person uses about 80 to 100 gallons of water a day. Even making a hamburger takes a lot of water. It can take a lot of water to raise wheat for the bun, to grow hay for the cattle, and to process the bread and beef. Cheese, anyone? Dairy cows also drink water, and it's in the grass they eat. So scientists estimate it takes 660 gallons of water to make your hamburger.
That's a lot. Do we have enough water?
That's a good question. Sometimes we don't. Many parts of the world are in a drought. That is, they don't have enough rainwater for their crops and people. And sometimes we take water for granted. We pollute it with chemicals. And when water is contaminated, we can't drink it or cook with it, and it endangers animals and plants. And sometimes we can waste water by doing things like not turning off the faucet or letting our sprinklers run too long. We have a limited amount of clean water to eat and drink, and to water our crops and animals. You need to do what you can to conserve water and keep it clean.
Okay, here's a riddle for you. What did the ocean say to the sea?
I don't know.
It didn't say anything. It just waved.
And joining me now to answer your questions about water are Jan Bowles, the Director of Environmental Science, Water Resources, and Professional Science Master's Program, and a Professor of Watershed Hydrology and Water Quality at the University of Idaho. And Sarah Godsey is an Assistant Professor in the Department of Geosciences at Idaho State University. Thank you both for joining us.
Thanks very much.
Thank you very much.
Okay, let's go to your questions.
Hello, my name is Brianna and I'm from Basin Elementary. My question is, what is water made out of?
So Brianna, water is made out of oxygen and hydrogen atoms, and they're put together in a really interesting way. They're put together in a way so that they're a polar molecule, which means that if you imagine that the oxygen is my head and the hydrogen atoms are my shoulders, then they're sort of a little bit off balance, and that is really important for water because it makes it a charged molecule, and it makes it have all these unique properties that help to make life on Earth possible.
Hi, my name is Aaliyah, and I go to Kamiah Elementary School in Kamiah, Idaho. My question is, where does water come from?
So, Lena, that's a really good question. We typically refer to water as coming through a cycle, the hydrologic cycle, which means water comes from the clouds. We could start with the clouds and then it moves around as it falls as rain or snow. After that, it might hit the land surface and move from there to different places. And so there is really not one place that water ever comes from because it keeps cycling around and around.
Cameron asks, why does water have no color?
It's true that water has no color if you look through a glass because the light does go through. But if you look at deeper water systems like the ocean or a swimming pool, other places like that, there is actually a coloration to the water. And that comes from the dissolved particles. And the color we see is actually everything that does not reflect back to our eyes. So it's an opposite of what reflects back. And so it all depends on the kind of particles in the water as to what color we might see. But yeah, on the small distance in a glass, it usually is looking as there is no color.
Hi, my name is Kendall. I go to Adams Elementary School. My question is, how is the water I drink made safe?
Well, this comes back to understanding where the water is coming from. And typically when we have water coming into our houses, it has been treated by the city. And the city has a water department, and they are responsible for making sure that the water that comes to the tap is safe. And most cities will have a report out that you and your parents could go and find that tells you exactly what they have found in the water. And that doesn't mean that there's nothing in the water that we inhale in addition to the water molecules, but it is below any level of concern for the citizen.
So if you're on well water and you're not on city water, then one of the things that you often need to do is you need to test your water regularly to make sure that anything that's in your water is not above those levels that are unsafe for human consumption or for us to drink. And so it's really important that if you're on a well and it's not tested by a city and you don't receive that report that says your water is safe, that you do check in and make sure that your water is safe. And there's a bunch of different ways that you can treat water. One of the best ways to make sure that the water is safe is to make sure that wherever the water is falling, when it originally falls as snow or as rain, that area is as protected as it can be so that you don't have to spend a whole lot of money cleaning up water. It's a lot easier to make sure that it's clean and safe to begin with as opposed to cleaning up your mess afterwards.
Adriana asks, do we drink water that was on the earth millions of years ago?
This is one of my favorite questions because you can actually calculate the likelihood that you're drinking in your particular glass of water a molecule of water that was drunk by Abraham Lincoln or George Washington or Genghis Khan, for example. And the likelihood is really high because there's just so many water molecules in a particular glass of water. So The answer is yes, we're drinking water molecules that have been cycling around and around in the hydrologic cycle for a really long time.
Hello, my name is Paige, and I go to Adams Elementary. My question is, why does my faucet water stain my sink brown?
Well, Paige, it's hard to know exactly what the reason is in your sink, but it's pretty common that the combination of water and oxygen can allow the metal parts of our sink to rust. And so that rust often creates that brown color that you see, which might be what's causing your sink to be stained brown.
Hi, my name is Brandon, and I go to Kamiah Elementary School in Idaho. My question is, how does water evaporate from the ground to earth to the sky?
So water molecules are always in motion, depending on how the temperature of the water affects that. And so when water is warmer, it will have a lot of motion, and because the water itself is a saturated system, so there's no air or little air in it, it looks at the difference between the concentration of water in the liquid versus in the air. And if the air is really dry and there's few water molecules in the vapor phase, then there's going to be a difference between them, a gradient between the two. And so the water molecules in the surface are going to jump out into the vapor phase. And it happens because there's energy in the system.
Water is usually measured in acre-feet. 1 acre-foot of water would fill a football field 1 foot deep. That's almost 360,000 gallons of water. That's enough to supply all the water needs for 2 households for a whole year.
Hi, my name is Katie and I'm from Basin Elementary. My question is, how much of the world's water is polluted?
That's a big question. You know that the world's water the majority of it is made up of oceans. And we don't have a good amount of testing to know how much of that water is polluted. We're mostly concerned testing waters that are fresh water, so rivers and lakes and groundwater. And even then, we may not know it for the entire world. To say what you just asked is a big question, how much of our water is polluted. But let's make at least a guess and say what we think. So there are lots of waters that have a level of chemical constituents that we are concerned with something that's called beneficial uses. And if a beneficial use is, say, drinking water, then we would say probably the sources that we have for that are not typically polluted, because we wouldn't want to do that. But if it comes to fish or the natural world, we have some places where we are concerned. And you may imagine where this can happen is where we have most of our human activity, is where most of that water might be polluted.
Elijah asks, is there water under the Earth's crust?
Elijah would like to know something that's really, really important for Earth's history. And it's the source of a lot of the water that we have at the surface of the Earth now. Our really thin atmosphere keeps in a lot of the water that's come to the surface through volcanic eruptions. And so, yes, there's water beneath the surface of the Earth. And a lot of the water that's beneath the surface of the Earth, or that was beneath the surface of the Earth in the past, is now at the surface of the Earth because it's come up to the surface through volcanic eruptions. That amount of water beneath our feet actually can have an impact on what happens during an earthquake, for example. And so if there's an area with a lot of water or a little bit of water, that can affect the shaking, or if there's a volcanic eruption, it can affect the type of volcanic eruption that occurs.
Hi, my name is Gavin and I go to Adams Elementary. I was wondering if groundwater is always clean.
I would say no, it's not always clean. And it depends where you are. The deep groundwater is typically clean. Because what happens is we drill our wells and we go into there, we test that water and we make sure it's clean, and otherwise we go deeper until it's clean enough for us to draw it up. But there's also shallow groundwater. And you imagine places where water is only 6 feet or 2 feet below the surface, and then it's likely that it is influenced by any activity that happens at the surface. So as we all know, we do farming, we do lawn care, we do other things at the surface, and those shallow systems could then have at least an influence of what we do. Now, in order to call it polluted, we have to be careful, because we tend to use the word pollution if it goes above a certain concentration, a certain standard that we deem safe or not safe. And if it's not higher than that standard, we wouldn't call it polluted. So you have to be just a bit of a nuance on that.
Hi, my name is Bridget, and I go to Kamiah Elementary School in Kamiah, Idaho. My question is, if minerals are in water, then why can't you see them?
So the stuff that's in water, there's lots of different things that it can carry along. The stuff that we can see, a lot of times, if water is really turbid or brown colored, the stuff that we can see is what's known as suspended sediments. And then there's also materials, like the ones that you've referred to, that are dissolved materials. And those are so tiny that our eyes can't see them. And so sometimes when we're looking at whether or not there's things in water besides the water itself, sometimes we can rely on our visual cues, whether it's brown or cloudy or clear, but other times we need to actually rely on chemical tests to let us know whether the things that are dissolved in the water that we can't see, that are too small, are actually there or not.
Gabe would like to know, can you die by drinking too much water?
Yes, you can. If you take in a lot of water, your body has a limited ability to take it out through after it's gone through the intestinal system. It has to go through the kidneys, and the kidneys have to transport it away through urination. If we don't have the capacity to do it fast enough, where is the water going to go? The water will probably go into our cells, right? And so there are certain cells that when they get a lot of water in them, they can expand. But there are other cells that cannot. One example of a cell that cannot expand is our brain cells. And so you will start getting severe headaches, and over time, the system will fail.
Rivers change the land through which they flow. They give us water to drink, they give us energy to convert to electricity, and they give plants and animals a place to live. So let's learn a little bit more about rivers. Most rivers start with rain or snow. As snow melts or as rain falls, the water collects together and runs downhill. When enough water gets together, it's called a creek. Creeks form into streams, and streams form into rivers. Some rivers come from springs, underground sources of water that bubble up or spill out.
Come aboard. I'm Steve. This is the Thousand Spring stretch of the Snake River. From here it goes through Strike up to the Columbia River in northern Idaho.
Rivers, like the Snake, have two banks. An outer bank is more worn away. The water carries away the rocks and sand, depositing it on the bottom of the river. That's called the river bottom. The water can also deposit the dirt and rocks on the inner bank. This constant moving of rock and dirt is called erosion.
Have you ever wondered why a river rock is so smooth? Well, the river tumbles the rock round and round, wearing off all the sharp edges. That's erosion too.
These rounded rocks over here are called melon rocks. They came down with the flood, being tumbled. That's how they got rounded. And they're deposited along the inner bank of the river.
The course or path of a river can erode the landscape. Slower moving waters find the easiest way to get around obstacles. That means a river's course can bend and turn. Those bends are called meanders. An oxbow happens when a river bends back on itself, forming a U shape. And waterfalls happen when a river or stream tumbles over a cliff. And did you know that glaciers are just frozen rivers of ice? Glaciers move very slowly, but like a river, they can erode away and reshape the land. Over thousands of years, a river can carve out a valley, create a canyon, or smooth out a plain. Rivers are a powerful force.
This is Blue Heart. Look down, you'll see the springs coming up.
What causes the sand to bubble?
It's the spring water finding its way out, and that's how it's coming through the sand, it's bubbling. And that blue is actually a gray sand. real fine sand. But with the spring water and the daylight makes it look blue. This is the 13th largest spring in North America. This water is always 58 degrees all year long.
The flow of the river is called its current. The faster the current, the faster the water moves. Rapids form when the hard rock underneath the riverbed slopes up or is tilted. The water flows over that uneven surface, causing it to churn, becoming whitewater. Too much water can do a lot of damage. In 1976, when the Teton Dam failed, millions of gallons of water poured out. The Teton River became a raging wall of water, wiping out whole towns. But usually, rivers are places of life.
It's an otter, all right. Don't see too many of them here.
Rivers are home to lots of different kinds of fish and birds and other wildlife. People live on the river too. Rivers are used to make electricity and for recreation. And if you're lucky enough to go with Steve on this part of the Snake, you may just get wet.
Oh yeah! Oh no, it's so fun.
Hello, my name is Ariana and I'm from Basin Elementary. Today my question is, how does water help plants stay alive?
So water is really important for plants, as I'm sure you guessed by asking your question. And plants use water in the process of photosynthesis. And so there's actually a continuum of water from the soil all the way up through the roots, through the trunk, out into the branches and out into the leaves of trees. And that is water that's moving all the way through the plant, and it's regulated by some special cells on leaves that are called stomata. And they can open and close depending upon how the plant wants to photosynthesize. And so if the plant wants to photosynthesize a lot, then they open up wide and they can let in carbon dioxide that the plant needs to photosynthesize. And at the same time, water escapes through those special cells, those stomatal cells. And those, if the plant decides, say during the night when there's no light available for photosynthesizing, the plant can close those stomata, and so that there's less water that escapes to the atmosphere through the plant from the soil.
Hi, my name is Alex. I go to Adams Elementary. My question is, when's the best time of day to water your lawn?
Well, that's a really great question because a lot of people are confused about this. So we must understand that the water that we put on the lawn needs to soak in to get to the roots. And if you take 2 times in the day, you can take 6 o'clock in the morning, or you can take right at noon, middle of the day. Well, we know that the sun is likely out in the middle of the day and the sun is just coming up at 6 in the morning. And most of the energy that is used to generate, to bring water back out before it even gets to the roots is because of the solar radiation from the sun. So you would think it's better to wait to make sure that you don't have the influence of the sun at its maximum level. So most people would water in the morning, in the early morning hours, or you could conceivably do it later at night, as long as you don't flood your roots and they may not be happy. So don't avoid the middle of the day when the sun is at its highest energy level.
Braden would like to know, how does the moon control our water when it's 238,900 miles away?
That's a good question. It seems like something that's so far away shouldn't have such a big impact, but it turns out that gravity can act even when it's not directly touching us or the Earth, right? The Earth and the moon interact with one another even though they're not directly touching. So gravity can act at a really large distance and can cause the tides and can affect how the ocean is moving. We're familiar with things that can act at a distance in some ways, right? From energy that's moved to us through radiation. So even if we're far away from our fireplace and not directly touching the flame, we can still feel the heat from the fire. So in some senses, that's analogous to how it is that gravity and the moon can affect water on Earth.
Fran would like to know, how much water is on Earth?
A lot. Let's assume that you mean water in the oceans, water in the ground, water in the rivers, and water in the lakes. I looked up a number, and it's like an amazing amount of water. Let's imagine, if you can imagine a mile in the north-south direction, and a mile in the east-west direction, and then a mile up way high, that's a cubic mile. Well, there are over 300 million cubic miles of water on Earth. But that includes the oceans, and the oceans are approximately 97.5% of the total water on Earth. So maybe we want to look and see how much fresh water is there. So then it becomes a small 2.5% of that. And then we can say, well, but wait, some of that water isn't even available to us because it is so deep into the ground, or it's frozen, and then we really have to only count maybe 1%. But if I gave you a number on the order of millions of cubic miles, and then 1% of that, it's still a whole lot of water. It's hard to imagine that much water.
Another way that we could think about that is that if we took all the water on Earth, all the water that's in the glaciers and in the oceans and in the atmosphere and in the lakes and the rivers, and we spread it out evenly across the entire Earth's surface, then we would have a layer of water that's about 2 miles deep all over the entire Earth's surface.
Jan, before we run out of time, why did you pick a job working with water?
I'm from a country, the Netherlands, where water is really, really important. I grew up understanding that too much water is a bad thing and too little water is not a good thing. And I carried that with me in my interest throughout my career.
And Sarah, if someone is interested in finding a job working with water, what should he or she study in school?
So I didn't know growing up that one could even study water. I just knew that it was really fun to study sciences and to be outside and to study math. And all of those things have been really helpful as I've gone into this career, even though I didn't know that I needed them when I got started.
I'm sorry we've run out of time. Thank you both for joining us.
Thank you.
It was a great pleasure. These were good questions.
And thanks also to the folks here at the Boise Watershed Environmental Education Center for hosting us. Do you have a question for one of our future shows? You can email it or send it as a video question, recorded on your cell phone, tablet, or webcam. Or if you're an educator, we'll even lend you a camera. And if you send in a question, you and your class can win prizes. Our last prize winner was Josh in Mrs. Efa's class at Galileo STEM Academy in Eagle. Now, to find out more about today's topic, go to the water section of the Science Trek website for facts, links, lesson plans, and more. Or watch Science Trek, the web show. So send in your questions, and each week, check out my blog with the latest science news for kids. You'll find it all at idahoptv.org/science-trek. Thanks for joining us, and we'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.